Okay, so the capacitor C is at 15 microfarad, and the solenoid sinusoidal AC sub E and F. The device operates at the amplitude E and maximum voltage E and is 36 volt and frequency is 60 Hz. A. What are the potential different VCT across the capacitor and the amplitude VC or the VCT? B. What are the current ICT in the circuit as a function of time and the amplitude IC or the ICT? So in this case, we can calculate the VCT. VCT is E and is equal to the 36 volt. So that we write down the equation. VCT is equal to the voltage at the any times are VCT. So the maximum voltage E and sine omega t. So in this case, E and is 36 sine omega t. So omega can be calculated. Omega is 2 by f. So this is the angular velocity. So the 2 by multiply and frequency is 60. So you got 125. So the VCT is equal to 36 sine 125 t. And B. What are the current ICT? So current I can be calculated. IC is any value is the IC maximum multiplied sine omega t minus pi. So that will the IC sine omega t plus pi by 2. So the AC is a capacitive reactance. This is the 1 by 2 by FC. So 1 by 2 by 3 by 1416. A is a 60 and the capacitor value is already given as 15 microfarad. 15 to the power minus 6. So you got 177 ohm. So the IC is a VC by AC. So the maximum voltage is 36 volt. AC is 177. You got a 0.203 ampere. And therefore, we write down this equation here. IC value we already got is 0.203. So we substitute 0.203 sine 125 t plus pi by 2 ampere. So the magnetic materials are dimagnetism, paramagnetism, and ferromagnetism. Dimagnetism is opposite magnetic field. It can happen at very little magnetic field. Paramagnetism means it's produces a magnetic field. If it produces a magnetism, when the magnetic field is applied, once the magnetic field disappears, the magnetism also disappears. Ferromagnetism means that it can retain the same magnetism. So that when you apply this, we apply the magnetic field, those are material become the magnetic properties, they possess the magnetic properties. So even those are the magnetic fields remote, they still retain the magnetic properties. So this is the magnetism material. So traveling the electromagnetic wave. So electromagnetic waves are energy, so we give to the send to the LC oscillator. So this is a transformer, so this is a connect to the transmission line and there's a electric dipole antenna. So this dipole antenna it produces a magnetic field. So those magnetic fields are moving around. So those magnetic fields we can calculate. This is a magnetic waveform. So the waveform possesses energy voltage. The voltage is equal to EF sine KH plus omega t. K is a wave constant, A is a horizontal distance, T is a time, and omega is a angular velocity. So E is maximum voltage. In the meantime, the dome magnetic waveform also possesses a magnetism. The magnetism can also be calculated. P is equal to PF sine KH minus omega t. So in this case, the K constant, omega is 2 by F, E is a voltage. P is a magnetic flux density. The speed of the electromagnetic waveform can also be calculated. C is equal to 1 divided by square root of mu 0 into E. So mu 0 is the permeability, E is a voltage. Okay, so this is for the magnetic properties. The next topic is the atoms. So atoms are the very smallest particles in any materials. So they got the special properties. They are stable. Atoms are stable. Atoms are combined with each other. Atoms are put together systematically across them with the ionization energy. So this is also the horizontal is a line is a horizontal scale atomic number, vertical scale is ionization energy. So we can arrange the atom, hydrogen, sodium, and nitrogen, potassium, argon, phosphorus, chromium, rubidium. So those things we can put. So depending on ionization energy and the atomic number, we can draw the graph. So this is for the atomic chart. So the atom also possess the electrical properties. So they has a resistivity rho, temperature coefficient alpha, and there's a number density of the charged particles. And depending on the number of density of the charged particles, it can determine the either the atom is insulator or the semiconductors or the conductor. And so the insulators are the highest band that containing the electron is completely filled and is separated from the bigger band. So the about it by energy care. So normally the bands are completely filled with the electron, and so the electrons are the band and the biggest energy band. They are separated by the energy cap. So high energy is applied to emit the electron. So those are the insulator. The metals are the higher bands that contains any electron is partially filled. So the inner metals are the sound of not all the bands are partially filled with the electron. That they are there with the electron is many are free electrons. So those free electrons can be moving from the one place to another place. When we apply the energy or the excitation voltage, electron can be moved from the one place to another place. So this is what the metal has this property.